Hello students, so welcome back to the lecture number 21 of the chapter number 7, and in this lecture we will solve the question number 4 from the exercise 7.3. Okay, so let's start the question. So the question is, BE and CF are two equal altitudes of triangle ABC. So let us first draw a triangle ABC. It is a triangle ABC. Now in this triangle there are two altitudes. Altitude means what is altitude? Altitude is a line which is perpendicular to a base and started from a opposite vertex. I have told you this is altitude. If ABC is a triangle, then AD is known as altitude of the triangle ABC on the side BC if it is perpendicular to BC. That means AD is perpendicular on BC. Understood? I have told you this. And now, since there are two altitudes, what are the altitudes? BE and CF. So we have to start drawing the altitude from the point B. Okay. So from the point B, so on the opposite side. So this is the first altitude, BE, since it is perpendicular. Okay. And CF. So we have start drawing from the vertex C. So let's draw CF. It is also perpendicular. So it is given BE is perpendicular on the side AC. This is given. And CF is perpendicular on the side AB. And also it is given both the altitudes are equal. That means BE is equal to CF, it is given, and BE is equal to CF. Okay, so BE distance is equal to CF distance. Now from this data we have to prove that using RHS congruency, prove triangle ABC is an isosceles triangle. Okay, so what we have to prove? To prove ABC is an isosceles triangle, but using which congruency? It is already given. Okay, it is already given. You have to use and only use this congruency. Okay, by RHS congruency. You should not use any other congruency, neither ASA, nor SAS. Okay, congruency. So let's prove it. How can you prove that ABC is an isosceles triangle having AB side is equal to AC side? It means isosceles triangle, so we have to prove that ABC is an isosceles triangle, or you can say AB side is equal to AC side. We have to prove this. Okay, using RHS congruency. So for this we have to compare two triangles. Which two triangles? For this we have to compare this triangle. Which triangle? Just read my hand. This triangle. BFC. So between triangle BFC and which triangle? This one. CEB. Okay, one is BFC, another is CEB, and CEB triangle. Okay, so what are the three conditions here? Here for the triangle BFC, for this triangle BFC, okay, this angle is 90 degree. Similarly for the triangle CEB, okay, this angle is also 90 degree. So you can write BFC angle is equal to CEB angle is equal to 90 degree. This stands for right angle. Okay, right angle. It is given. Why? Because B is perpendicular on AC and CF is perpendicular on AB. You can write the reason here, no problem. B is perpendicular on AC and CF is perpendicular on AB. Done. Next, see, for the triangle BFC, BC is a side. Similarly, for the triangle CEB, BC is also another side. So BC is the common side to both the triangle. So you can write BC is equal to BC common side. Right? Third condition is for the triangle BFC, this triangle, this distance FC or you can say CF, and for the triangle CEB, this distance BE, both are equal. Why? What is the reason that both are equal? Because BE is an altitude, CF is an altitude, and already it is given that BE is equal to CF. BE is equal to CF. So you can write that BE is equal to CF. Okay? Since it is given. Now let us identify which three conditions it follows. So for the triangle BFC, if we will consider, then what we have taken? We have taken this angle. This stands for right angle. Now we have taken BC side. See, BC side. Tell me, BC side is known as the side of the triangle BFC or the hypotenuse. What is an hypotenuse? A hypotenuse is a side which lies just opposite to the 90 degree. Just opposite. So if this angle is 90 degree, then its opposite side is BC. So BC is the hypotenuse. So the second thing is H. Next is for the triangle BFC, we have taken this side FC. So FC stands for side. So by RHS congruency, we can write that this triangle is congruent to this triangle. Understood? Hence, by RHS congruency, triangle BFC is congruent to the triangle CEB. This is clear. Okay, now we have proved what? We have proved that this small triangle BFC is congruent to the triangle CEB. This is clear. But what we need to prove? We have to prove that ABC is an isosceles triangle, or this side AB is equal to this side AC. How we can prove it? It is also very easy. See, for BFC triangle, only consider BFC triangle. Okay, for BFC triangle, this is an angle. Yes or no? Yes. So B angle is an angle for the triangle BFC. Right. Similarly, for the triangle CEB, this one is an angle for the triangle CEB. Yes or no? Yes. So C is an angle for the triangle CE and B. Now, as we have proved that BFC triangle is congruent to CEB triangle. Okay, is congruent to CEB triangle. Then according to the axiom 7.2, we can write that their corresponding angle must be equal. Okay, so directly we can write angle B is equal to angle C. As if any two triangles are congruent, then their corresponding angles, their corresponding sides will be equal. This is CPCT. Hence, you can write angle B is equal to angle C. Okay, by axiom 7.2. What we have found? We have found this angle is equal to this angle. Now, consider the triangle ABC. Okay, for triangle ABC, since we have proved what? That this angle is equal to this angle. For the triangle ABC, this angle is equal to this angle. Now remind the theorem 7.3. We know if any two angles are equal, then their opposite sides must be equal. If B angle is equal to C angle, then the opposite side of B angle is AC. First we have write for the triangle ABC, B is equal to C. By proof, we have found it here. Now, the opposite side of angle B is AC, and the opposite side of angle C is AB. Okay, so since B angle is equal to C angle, so by theorem 7.3, the opposite sides must be equal. So AC must be equal to AB. By theorem 7.3. So what we have found lastly? We have found for the triangle ABC, this side AC is equal to AB. It means what? It means ABC is an isosceles triangle. Clear? It means ABC is an isosceles triangle. And now it is proved. And we have proved by using which congruency? Here we use only RHS congruency, and the question asks you to use only RHS congruency, not any other congruency like ASA, SAS, AS or SSS. Okay, so now we have proved that ABC is an isosceles triangle if the two altitude will be of equal length. Okay.